Hello student, let's begin with lecture 8 petroleum technology. In the previous lectures we studied about the properties and specifications of different petrochemicals that is obtained from the refinery. So today we will come to know about the diesel fuel. So diesel fuel, as you can see, it is stated as a mixture of hydrocarbons obtained from distillation of the crude oil. So it contains the mixture of many hydrocarbons, uh, and it is a distilled product coming after the distillation of the crude oil from a refinery. So the composition of diesel fuel is C12 to C20. It mainly includes the aromatic component, paraffins and naphthalene or naphthalene rings. And boiling point, it is having the 70 to 360 degree centigrade, and it is major fractions that is obtained from the refinery after the distillation of a crude oil into fractional distillation. Diesel fuel is basically called a diesel oil also because it is mostly used in diesel engines, and diesel engine is a type of internal combustion engine in which fuel intakes ignition, and ignition is without spark, and that result a compression of inlet air then the injection of the fuel. So therefore diesel fuel needs good compression ignition characteristics, and it is important property which are used to characterize diesel fuel is cetane number or cetane index, fuel volatility, density and viscosity, cold behavior and sulfur content. So these are the important characteristics properties. Based on that, the diesel is good diesel or bad diesel is characterized. Diesel is produced from various sources, most commonly being petroleum, and other sources are also exist that are biomass, animal fat, biogas, natural gas, coal liquefaction. So these are the different sources from where we get the diesel. And basically we have the petroleum diesel, synthetic diesel, biodiesel and hydrogenated oil fats, dimethyl ether. So these are the different type of diesels that are obtained from different sources. You see in this slide we have the parameters, units, euro 1, euro 2 and euro 3, euro 4 and euro 5. So these are the standards, different euros standards uh, for the diesel engines. So in at the top, the first column, you see the different year. These euros are launched in different years. Like 1993, the euro 1 was launched. So in cetane number, if you see the minimum cetane number was in 93 49, and then the cetane number is increased around 2009, and sulfur content was very high in euro 1 and very less in euro 5, that is 10. The flash point is almost constant, and you see the copper strip is 1, it is constant, and the water solid distillates are basically uh, you see initially it was around 520 and now it is 460. In specific gravity we have 0.82 to 86 in euro 1, and if you see in euro 5 we have 0.82 to 0.845. Similarly, distillation percentage in degree centigrade is initially it was 370, now it is 360. So the property of the diesel for characterization, we will discuss the different parameters. For the first is density. So using the density, you can check the uh, uh, poor petrol or good petrol. So at the petrol pump, when you verify the real characteristic of a petrol, first you will measure the density and you will match it with the characteristic table whether the density is coming uh, correct or not. If the density is not correct, that means the diesel is not pure. So the presence of different classes of hydrocarbon helps to estimate the density of diesel fuel. In diesel fuel, the density increases with increase in the number of carbon atom present in it. So how many carbon numbers are present? The density will measure. So the density will measure the percentage of carbon or carbon molecules present into it. So increasing order of density begins with paraffin, naphthalene and aromatics. So typically the density of diesel fuel ranges from 0.820 to 0.845 gram per milliliter. So this is the accurate and actual density of a pure petrol. If there is a density increases, then that means into the diesel we have more amount of carbon molecules, or the percentage of paraffin, naphthalenes and aromatic increases. Now the another characterizing property we have distillation curve. So the most significant characteristic of diesel fuel is distillation curve, that is representing the mixture of hundred of hydrocarbon in the fuel, and that is having different boiling point. So it is basically distillation curve represent the multi-component uh, of component present into the diesel. So distillation curve is drawn between the temperature and volume percentage of the diesel fuel. Higher the distillation point, the there will be the heavier the component in the diesel fuel, and the result of poor combustion in the engine. So that means if we have the heavier compound more into the diesel, then the performance of the engine is poor. And 95% distillation point is Euro 5 diesel is 360 degree centigrade. So 360 degree centigrade is basically your uh, the uh, percentage of the diesel fuel, that is the temperature and volume percentage of the diesel fuel, that is 360 degree centigrade temperature. Next property we have ignition quality. So ignition quality is characteristic parameter that is express the quality of the fuel. So in diesel fuel, the cetane or cetane index is used for this purpose for ignition quality, and cetane number uh, in Euro 5 the diesel is maintained at 51, and the cetane number is defined as a performance meter of the diesel fuel. The higher number represent the better performance of the diesel, and it depends upon the type of hydrocarbon present into the diesel. Which type of hydrocarbon we have? More aromatics, we have less cetane number. If the percentage of aromatic is low, the cetane number is high, and performance of engine is good. So in the parameter paraffins, the cetane number increases with increase in carbon number. So cetane number of naphthalene ranges from 40 to 70, while aromatics have 0 to 60. And generally the cetane of diesel fuel is estimated by the standard testing method cetane for diesel fuel, and that is ASTM D613. So this is the uh, distillation method, standard method for distillation, that is ASTM D613. So overall, if we talk about the cetane number should be uh, higher, and it should be less percentage of carbon amount, so that the engine should not create the knocking. Now talking about the appearance and odor, the first and most characteristic property of diesel fuel oil is appearance, and that is a strong indication of contamination test into it. If it looks like a different color, or it's look like a dark color, that means we have more presence of uh, impurities into the diesel. So thus the visual inspection of diesel fuel is requirement before the delivery. A visual inspection is required because diesel looks like transparent. Diesel is colorless liquid, and any dark color shows the presence of impurity or high distillation of the diesel fuel. And odor of the diesel fuel should be acceptable, no unpleasant odor. Thus, presence of pleasant odor in the fuel represent indication of mercaptans in the fuel oil. So mercaptans, if the presence of mercaptan is there, it will show some odor. Or to identify uh, the diesel, sometimes mercaptan is added into the diesel fuel. Now neutralization number. So neutralization number measures the tendency of a fuel to corrode metals. It is measure of total acidity or inorganic presence in the fuel. And general method to measure the corrosivity test is ASTM D130. So this is the standard method that is called a corrosivity test. It measures that how much diesel is corrosive and what is the percentage of acid into the diesel. So basically uh, there should be minimum uh, percentage of acidic component into the diesel, otherwise it will become corrosive. Now another characteristic is cetane index. So cetane index is basically a technique to measure your cetane number. You can see the definition. Uh, Cetane index is defined as the estimation technique. So it is a estimation technique to approximate the cetane number for any fuel. So it will measure the cetane number in any fuel. So it utilizes a specific engine for approximation of cetane number for the fuel. In any specific engine, what will be the cetane number of the fuel? So that is this technique to measure the cetane number is called your cetane index. So certain we have certain standard and methods to measure the cetane number using the cetane index. So first one is we have ASTM D9976 and second one we have ASTM D4737. This is called the cetane index via four variable equations. Now next characteristic property, that is sulfur content. Sulfur content is very hazardous for the environment. It presents into the diesel. So in the Euro 5 you will see we have very less percentage of sulfur. This is highly hazardous for the environment. So sulfur content, as you can see, sulfur content in the fuel are highly dependent on the origin of crude oil. So if the crude oil have the origin um, from low sulfur content area or reservoir contains some low sulfur, then the diesel fuel will be more refined and it has the less percentage of sulfur. So it is a contamination of the fuel which is reduced via hydro treatment of the diesel fuel. So sulfur content is mostly removed from the hydro treatment, and it is a regulation to use low sulfur content fuel or almost zero sulfur fuel in automobiles for better engine performance. So if the sulfur content is higher, then engine performance also become less. So you need to use the zero sulfur fuel in your engines. The maximum sulfur content in Euro 5 diesel is maintained at less than 10 ppm. That is the standard in Euro 5. And Euro 5 diesel is called the ultra low sulfur diesel. This is also called the ultra low sulfur diesel. So this is more refined part of the Euro 5, that sulfur content is reduced very low. And the standard test method for sulfur content estimations, that Now the sulfur can be detected by these following methods. One is X-ray spectroscopy, and another is energy dispersive X-rays, and next is fluorescence spectroscopy using the ultraviolet fluorescence. Using these techniques, we can detect the percentage of sulfur into the diesel. Now the another characteristic property is carbon residue. So carbon residue, we can see it is defined as the burnt carbon content deposit via fuel burning or decomposed carbonaceous material of diesel fuel. Means after burning, how much carbon amount is left into the engine. That is the basically carbon residue. So if you read the definition, you see it is defined as the burned carbon content deposits via fuel burning or decomposed carbonaceous material of diesel fuel oil, and that is termed as a carbon residue. So it can be estimated via Ram's bottom carbon residue of petroleum product, and that has a method, that is ASTM D524 method. So using this method, you can find out that how much carbon residue is depositing after burning the fuel. Now next characteristic property of diesel fuel is heating value. This is important characteristic value. So heating value is basically defined as the total amount of energy released by the combustion of diesel fuel, and that is defined as the heating value. Means how much energy is being released once this fuel is burned. So it is generally expressed in terms of gross or net calorific value. So it is highly dependent on amount of water present in exhaust. So heating value is very important. Higher the heating value, the performance or the performance of the engine will be much better. Now next we will come to know, in this slide you see the diesel fuel specifications under the BIS standard or ISI standard 14601974. So these are the different characteristics, and these are their requirements. So you can see we have a flash point that is measured using the Penske Martin apparatus, that is 55 degrees centigrade, and different classes A, B, C classes. Kinematic viscosity is around 2 to 7.5, 2 to 7.5, 15 to 15.7, that to next it is up to maximum. So into the C standard we have the kinematic energy is increased. So carbon residue, we have Ram's bottom present percentage by weight, zero point 0.2, zero point 0.2, and here 1.5. cetane number we have 45, 40. Diesel index we have 48 and then 43. Distillation percentage we have 90, 90. Then copper strip corrosion 1, 1 and 2. Then water content present by the volume 0.05, 0.05. Sediment percent by the weight maximum 0.05, 0.05, 0.1 in class C. Then we have ash percent by weight maximum 0.01 in class A, and in class C we have 0.02. Acidity of QH per gram is 0.5 to 0.5, and we have sulfur content, that is 1.0, and then in class C we have zero point 0.8. Pour point we have 6%, 6 degree centigrade, 6 degree centigrade, and in C we have 6 degrees centigrade. So this was all a small information about the properties and specification of the diesel fuel. In the next lecture we will come to know about the properties and specification of another petroleum product. So thank you.